All right, so this entire unit is on volume. Okay, what is volume of something? Actually, before you answer that question, in the last unit we talked about perimeter or circumference, right? The distance around a circle. Before we talked about perimeter, so the distance around the room. We talked about area. What's area? Huh? What does the whole area mean? So like if I was talking about this room, for instance, and I wanted to know the perimeter, why would that be helpful for me? What could I use to talk about perimeter of this room? Like let's think if we were building a room or like redoing our room, what in this room would help us with perimeter? Like what would we need? The sides, okay. The what? No? So look around the outside of the room because we know we add up all the sides, right? So what on the outside of the room could we replace if I knew what the perimeter was? Like I want you to literally think about like redoing a room. What could I replace in this room if I knew what the perimeter was? Okay. What is this called? The baseboard. So I could replace a baseboard. I could put like a molding around for perimeter. So when I'm thinking about area, what would I replace when I'm talking about area? The carpet, the flooring, right? The area of the room is the whole bottom of the floor. Technically, if we want to talk about area, we could replace like the ceiling as well. Or if we need to know how much paint to use. Okay, we can find the area of a wall. Does that make sense? Okay, so volume, what do you think volume talks about? The space taken up, okay, where? Inside what? My hand? Volume, what's volume? We're tired today. What's volume? The whole thing. What do you mean by the whole thing?
How much you can fill up a shape or like a glass, how much you can fill up.
Okay, so how much we can fill something up, right? So if we're talking about this room and we wanted to fill it with water, I mean, that would be silly, but if we wanted to fill it with water, that would be the volume of this room. So a pool, for instance, all the water in a pool is the volume of the pool. When you're talking about, like everyone's hydro flasks, right? Your hydro flasks are 34 ounces, 40 ounces. It's how much water or liquid is inside your cup. Okay, it's important that we know the differences of those things. Are we okay with that?
You guys look so tired.
I know. Maybe we need to We're going to talk specifically about volume of cylinders and prisms. Who can tell me what a cylinder is or give me an example of a cylinder? Darian?
I think it's a can of tomatoes.
A can of tomatoes? That would be a cylinder. So any can, it can be tomatoes, it can be beans, it can be soup, right? Any can. That's specifically what we look at for cylinders. Kind of for the most part, our hydro flasks are cylinders minus the lid. We'll talk about prisms in a second. So let's draw a can. You ready? We're going to do some drawing. Oh. Okay. So it's easiest if you draw, and we're going to do it 3D, so it's easiest if you draw a circle. And then from your circle, we're going to drop down the sides. Okay, and then you're going to round out the bottom. And then I'm going to add a dotted line in the back so that I know that it's standing up. Some of you are better drawers than me, or worse, which is fine. You just need to know what the picture is, roughly. Everyone have a cylinder? Volume of a cylinder. This is super important. So this is something you need to box, highlight, circle, underline, listen to all the directions for. Volume of a cylinder is big B times a little h. And there's an important piece to why one's capitalized and one is not. So let's start with the H. What do you think H stands for? Height. Okay, so H is your height, how tall your cylinder is. Here's the important part. This big B, what would your assumption be on what that B stands for? Base. Okay. It actually stands for base area, or the area of the base. So base area, or the area of the base. So if I'm talking about a cylinder or a can, what is the shape of my base? A circle. Do you know how to find the area of a circle? So that's what we would replace with this B, is area of a circle, and then multiply it by the height. Okay, so B stands for base area. And we're going to use this formula again when we get to prisms, which is why base area is important. Okay, so let's try one. I'm going to say that my can has a radius of 5 meters and a height of 11 meters. That's not really a can at that point, but this cylinder has a radius of 5 meters and a height of 11 meters. So you told me that the cylinder has a base, which is a circle, correct? Okay, so base we're going to replace with pi r squared, because that's my formula for area of a circle. I'm not plugging anything in yet. So pi r squared is replaced with the big B, and then I still have my height. This unit, just like the last one, is super important as you write through the steps so that you know where you're going wrong, or I can figure out where you're going wrong and we can fix that. Okay, so base area, so it's a circle, times the height. We okay with that? What two pieces of information do we need to find the volume? The radius and the height. Do I have both of those? Okay, so volume equals pi times my radius squared times my height. So let's simplify it. Do we have our calculators? I'm going to have two answers still, just like we have, in terms of pi and our rounded answer. So let's start with in terms of pi. So I need to do 5 squared. 5 squared. 25 times that 11. So what's 25 times 11? 275. So my first answer is going to be 275 pi. Who thinks they know what our units are going to be? Annie? Meters cubed. So 275 pi meters cubed is my exact answer. And I'm just going to write it off to the side in terms of pi. Or my exact answer. Okay, so it's your exact answer or it's in terms of pi. So you'll see both of those directions. That's what we've been talking about. Now, if I want my rounded answer, what is 275 times pi? And let's round to the nearest tenth still. What's 275 times pi? Thank you. 863.9 meters cubed. And this is my rounded answer. How much math did your brain physically do? 5 squared, maybe? Okay, so if you're not using your calculator appropriately and or you don't use the correct formula, you're not going to get these questions right. So it's important that you understand the formula so that we can plug everything in. Okay, yes?
Why is it the third?
So volume is third because we're now, so perimeter, since it's just like a one-dimensional thing, it was just your units. Area became squared because you have this whole area here. And then volume, it's 3-dimensional, so it's cubed. Okay? Are we okay with that? Okay, let's draw another cylinder. Let's draw a bigger one. It doesn't have to be perfect, because this one is not. What is the base of this cylinder? What shape is the base of this cylinder? It's still a circle. I mean, it's not drawn very well, but it's still a circle. All cylinders are going to have a circular base. Okay? So for volume, our base is a circle, so pi r squared times the height of the whole thing. The circle's a base times the height of the whole thing. See if you can plug in the information, and don't let this one trick you, and find the volume. So I told you not to let this one trick you. What would be tricky about this problem? It gives you the diameter. We don't want the diameter, we want the radius. What is the radius of this circle? 8. Okay, so volume equals pi times the radius squared times the entire height. 8 squared, 64 times 4, 256 pi feet cubed. Should have been your exact answer. And then rounded to the nearest tenth, what did you get? 804.2 feet cubed. So the hardest part about these problems is 1, understanding the formula, and 2, using your calculator.
We're even measuring the cube.
Oh, feet cubed. Okay, what's a prism? Anyone know what a prism is?
God. Mine's going blank.
Okay, decide with your group what a prism is. So a prism is literally a box. Now it's going to have a lid, so it'll have a top and a bottom. And typically our prisms have the same top and bottom. So this opening's wider, right, than the bases, but they would be the same. So literally a cardboard box would be a prism. Now, we can have different shaped bases. So you can have a tissue box is a great example of a prism. And then the volume would be how many tissues you can fit inside-ish. Okay? But we can have different shapes for prisms, and we'll talk about that in a second. But let's draw a box. Do you know how to draw a box? Yes? Okay. If you don't, look up here. I'm going to make this super easy. So draw a square.
If you don't know how to draw a box, watch.
We're going to have a nice box on our paper. Now, in the middle of that square, you're going to draw another one that is the same. Exactly the same?
Not the only way to draw a box, so if you know another way, it's okay.
This is the only way I know how.
Yeah.
Okay. And then we're going to connect the corners. Look it. You drew your first box maybe.
Oh God, that's like my brain. I forgot how much these are in my brain.
I am not going to require you to draw these on your homework and on test, but you should know what the shape looks like, and we're drawing the basic ones today, okay? So our box has side lengths of 3 inches, 3 inches, and 3 inches. So it literally is, I don't want to say that yet. Okay, so our box has side lengths of 3 inches. We're using the exact same formula, so it's base area times the height. What is the shape of this box? A square. Okay, the shape of the box is a square. What is the formula for area of a square? Base times height, length times width. I'm going to use length times width because we already have a height that we're going to plug in there. So this is my B, right? It's the base area, and I'm multiplying it by the height. What is the length of my box? 3. What's the width of my box? 3. What's the height of my box? 3. And what is 3 times 3 times 3? 27. There is no rounded answer because it's exact. We don't have pi. Okay, so we have an exact answer. And here's kind of where the units come in. Because what's inches times inches times inches? Inches cubed. Okay, so our final answer is 27 inches cubed. Now the nice thing about this is, say you don't know which one's the length, the width, and the height, you're multiplying, so it doesn't really matter, right? Because we can multiply in any order. Are we okay with that? Okay. But I said that prisms have different shapes, shape bases. So this one's going to be fun. I think I'm actually going to flip to the back real quick. If they have room, they can use it. I just don't have room. Okay. We're going to draw this together, so make sure you follow along. Let's start by drawing a right triangle. Okay, so draw a right triangle. We're going to extend this piece out just a little bit. So I added like a, I don't know, a line there. Okay, and I'm going to extend a line out on the bottom as well. Not a lot. And we're going to connect those two. So is this kind of like a piece of pie? Or a piece of cheese? Okay, so the bottom and the top are the same shape. We're gonna add one more piece, but the bottom and the top are the same shape. Here's the hard part. Okay. From this corner here, we're gonna make it 3D. So from this corner here, we're gonna just do a dotted line up, not all the way. From my right angle, I'm going to do a dotted line to that corner there. And then my last dotted line is going to go from where I just connected to my far point. Do you see that 3D image a little bit? Okay, so it literally is like a slice of cheese. You have a top You have a bottom. The top and bottom are the triangles. Okay? Now, here's what's important. I want you to make a note on your paper. The top and bottom of prisms are the same shape. Top and bottoms of prisms are the same shape. This is super important as we're going to be solving. Because if you look at this, I see a couple different shapes. So once you're done writing that, I want you to put your pencil down so I know you're listening, and I want you to look up at the screen. So the top and bottom of prisms are the same shape. Okay. This piece here would be like a rectangle or a square, correct? How many rectangles and squares do you see that are that exact same size? Do you see any other rectangles that are that exact same size? No. Okay, so that can't be the base of your prism. I see a rectangle here, kind of. Do you see one that's exactly that same size? No. What do you see that doubles up? You have the triangle here, and you have that same triangle, if it was drawn perfectly, on the bottom. Okay, because there's a right angle here, and here's my triangle. It's just one on top of the other. Do you see that? Okay, super important. Now we're using the same formula, so we're using volume equals base area times height. What is the shape of my base? What is the shape of my base? What do I see two of? Triangle. So the shape of my base is a triangle. This stands for base area. What is the formula for area of a triangle? Formula for area of a triangle. Okay, so 1/2 the base times the height, or base times height divided by 2. So I'm replacing B with 1/2 the base times the height, and I still have the height of the whole thing. This is probably the trickiest problem. Okay, so I'm going to give you some numbers. I don't want you to solve anything because I guarantee I'm going to go with half of you will pick the wrong numbers because I'm going to give you more information than you need. So I'm going to give you numbers, and I want you to take 30 seconds or so with your group and discuss which ones you think should be plugged in. Okay? So there are some side links for you. I want you to take 30 seconds to a minute with your group and decide which numbers your base and height of triangle will be and the height of the entire prism will be. Who can tell me what they think the base and the height of the triangle are and why? The base and the height of the triangle, because that's what I'm looking for right here. Who can tell me what the base and the height of the triangle are and why? Rylan.
I think that the base and height is 6 and 8 because you don't want to put like the hypotenuse in because it's a right triangle.
Okay. Can we add to that a little bit? There's some, she hit it on the head, but I'm looking for like 2 words that we talked about in the last unit. So she said we can't use the hypotenuse. It's a right triangle. What did we talk about in the last unit?
Like the base and the height, they equal the right angle, or they like make.
So the base and the height of a triangle create a 90-degree angle. Do we remember that from the last unit or 2 units ago? When did we do that? 2 units ago when we did perimeter and area. Okay, so the base and the height of a triangle create a 90-degree angle. Those are the first 2 things you're going to pull. The base and the height of a triangle create a 90-degree angle. It doesn't matter which one's the base. It doesn't matter which one's the height because you're multiplying. So right now I have volume equals 1/2 the base times the height. Now, what is the height of the entire prism? How much does it pop up? How much does it pop up? I'm hearing either 10 or 8. So someone give me a confident answer and tell me why you're choosing either 10 or 8. Because we've already used these two, so we can't use those again. Annie? Which one are you choosing?
8 yards.
8 yards? Why?
Because we already said his height and
Oh, I see. But that was the base times height of just
Just a
simple
triangle.
Just one triangle.
So we're looking at this 8 yards versus this 10 yards.
Yvonne, what do you got?
8 yards because 10 is the hypotenuse of the triangle.
Okay, so 10 is the hypotenuse of the triangle. 8 is actually how much it pops up. It's how big your piece of pie is or how big your cheese is.
See this triangle here? There's another one identical to it below it. So imagine this is the one connecting those two triangles. That makes sense? It's your connected piece.
Yep.
That connected piece is your
I
height
like that.
on the triangle.
So the height, I like that. The height connects the bases. The height connects the bases. It's a good way to remember it, especially for these triangle problems. So I'm going to put in times 8. So your calculator is going to do now all this work for you. 8 times 6 times 8 divided by 2 gives you 8 times 6 times 8 divided by 2 gives you what? Haley?
96.
192. So 192 yards cubed should be your final answer. We're going to spend today doing this, and we're actually going to do another practice day. But I'm going to give you one more type of problem that you're going to see. Okay, ready for our next drawing? If you need to go to the back, that's fine. Just remember it's still page 35. So I need everyone to draw a triangle. Okay. On the bottom of that triangle, I want you to draw a rectangle. Okay. From the top of your triangle, I just want you to do a dotted line, not too far down. I might go a little further because my triangle is bigger. And then from the bottom of your rectangle, you're going to do a dotted line up to that piece you did just there. Everyone see this slice of cheese? Okay. Now the difference between this slice and this slice is the right triangle is created. So this is kind of like, this would be like a sheet cake and you cut it right out of the side. This is more of like a circular piece that you cut out. Okay. So I'm going to give you some information. Okay, I drew in another line, and hopefully it doesn't confuse you too much. Okay, we're going to go through this one. I will give you a hint, though. Anytime you see a triangle in any of these problems, that is going to be your base. Okay, if you see a triangle, it's going to be your base. That says 6.1 kilometers, and that's right up the middle of the triangle. Why is that going to be important to us? Why is that 6.1 going to be important? It's the height of the triangle. Why is it the height of the triangle? It connects to the base and creates a 90-degree angle. Okay, so, yep. Okay, so listen. Shh. This 6.1 is super important. It's the height of the triangle because it connects to the base and creates a 90-degree angle, which means 6.1 is my height and 10 is my base. That is for the triangle only. So if I ignore everything else, do you see that right triangle? Or sorry, do you see the triangle with the right angle? Okay, so you have the base and the height. What is the height of the prism? How much does it pop up? What connects the top and the bottom? The 3. So we still have 1/2 base times height. That's the area of the triangle times the height of the entire prism. What's my base? What's the base of the triangle? 10. What's the height of the triangle? 6.1. And what's the height of the entire prism? 3. So in your calculator. What'd we get? 90 what? You should have gotten 91.5 kilometers cubed. Okay. 91.5 kilometers cubed. Again, we're going to spend some time doing this because if we can get this lesson down, the ones to follow are going to be a whole lot easier. So let's do a little bit of a recap. I want you to write these things down because they're going to be important.
Yeah.
Okay. What shapes of bases did we have in this lesson? What shapes did we have? Circles. What else? A square, and I'm going to say square rectangle because it could be a rectangle too. And a triangle. Why are the bases important? Why are the bases important? Why are the bases important? Okay, so we needed to find the volume because the big B stands for what? Base area. So just in case anyone didn't listen for the last 35 minutes, area of a circle is what? Pi r squared. Area of a circle. What's the area of rectangles and squares? Length times width. What's the area of a triangle? One half the base times the height, or base times height divided by 2. You need those area formulas to solve every single one of these problems. Now, one last recap. We have two different types of triangles we looked at. We looked at a right triangle. I need you to focus. And then we had a triangle that looked like this. What's important about triangles and finding the area? The base and the height. Okay, listen to the question, y'all. Super important. And you think it's easy, but I promise you someone's going to mess it up because they're not listening or don't understand. When we're talking about finding area of triangles, what is super important when you're choosing those numbers? Haley.
That the height connects to the base.
And?
Right angle.
And it creates a 90-degree angle. The base, I'm going to put this question on your test or quiz. Listen carefully. The important thing about finding areas of triangles is that the base and the height create a 90-degree angle. It's going to be a quiz or test question. Be prepared. What's important about area of triangles? The base and the height create a 90-degree angle. Base and height. The base and height create a 90-degree angle. On this triangle here, it's going to be my base and my height. What's important about finding area of triangles? Okay, let's try that again. This is going to be a question on a test or a quiz. What is important about finding the base? Nope. What is important about finding the area of a triangle?
The base and the height and the 90-degree angle.
It's better. The base and the height create a 90-degree angle. Super important. If you remember nothing, I need you to remember that. Because you will choose the wrong numbers if you don't remember that. Now that I'm tired. Okay.